Good morning, sir. So my audio.
Okay, sir. I can start, sir. Thank you, sir. A very good morning to everyone present here. I, Surmai Mukherjee, student of final year from Electronics and Telecommunication branch, take this humble opportunity to welcome you all to today's inaugural function for 2 days workshop on IoT applications using embedded systems. This event is organized by G21 College of Engineering, Nagpur, in association with IEEE 2021 Region 10, IEEE Bombay Section, and IEEE Nagpur Subsection under IEEE 2021 Region 10 Capacity Building Workshop under Educational Activity and CoE IoT. For those of you who are not much aware of IEEE, IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire a global community to innovate for a better tomorrow. So various conferences, highly cited publications, technology standards, and professional and educational activities. IEEE is a trusted voice for engineering, computing, and technology information around the globe. Let's begin today's inaugural program by seeking the blessings of Ma Saraswati, the very goddess of knowledge and art, represent the free flow of wisdom and consciousness. She is the mother of Vedas and chants directed to her, called the Saraswati Vandana, often being the end Vedic lesson. So to have blessings and marking the start of an event, I would request Assistant Professor IT Department, Professor Sankada Vasilwar, to recite Saraswati Vandana and seal the meet with all the positive energy.
जय जय हे भगवती सुरभारती तव चरणों प्रणमाम जय जय हे भगवती सुरभारती तव चरणों प्रणमाम स्वमति शरण्या त्रिभुवनरण्या सुरमुनि वंदित चरणा नवरस मधुरा सरिता मुकुरा स्मृति रुचि रुचिराभरणा जय जय हे भगवती सुरभारती तव चरणों प्रणमाम जय जय हे भगवती सुरभारती तव चरणों प्रणमाम.
Thank you, ma'am. At this inaugural function, we have with us esteemed personalities. It's my proud privilege to introduce our chief guest, Dr. B. Satyanarayana, Chair, IEEE Bombay Section, Dr. Abhay Gandhi, Chair, IEEE Nagpur Subsection, and Dr. Sachin Ontwale, Director of G21 College of Engineering, Nagpur. I once again humbly welcome everyone to the August House. The aim of IEEE is for advancing technology for the benefit of humanity, and so is the aim of today's workshop. I now request Head of Department of Electronics Engineering, GHRC, and Coordinator, Dr. Lakshman Thackeray, sir, to kindly read out the preamble.
Thank you, Surmai. Good morning, one and all present here. Today's chief guest, Dr. B. Satyanarayana, sir, Chair, IEEE Bombay Section. Dr. Abhay Gandhi, sir, Chair, IEEE Nagpur Subsection. Our beloved Director, Dr. Sachin Ontwale, sir, GHRC Nagpur. Deputy Director, Dean, Head, Faculty, and dear participants. On the behalf of GHRC Nagpur, I, Dr. Lakshman Thackeray, Coordinator, welcome you all for inaugural function of the workshop on IoT applications using embedded systems sponsored by IEEE Design Capacity Building Workshop under Educational Activity. At the outset, we are thankful IEEE Region Team, IEEE Bombay Section, and IEEE Nagpur Subsection for exceptional and unconditional support to us for today's online workshop on very challenging areas of IoT and embedded systems. For this 2 days of workshop, total 6 speakers from IIT Indore, Institute of Industrial and Computer Management, Research Pune, SIP University Pune, Bharat Institute of Higher Education and Research Chennai are invited for sessions and workshop for this workshop. The resource persons as a speaker who will deliver the guest lectures and hands-on are Dr. Vimal Bhatia from IIT Indore, Dr. Purna Shankar, Professor, Institute of Industrial and Computer Management and Research Pune, Dr. Ajay Vishnu, Director, Center for Industrial Mathematics, Pune, Dr. Rahul Jawari, SIP University, Delhi, Dr. Ranvi Holidas, Bharat Institute of Higher Education and Research, Chennai. Sir, we have received more than 232 participants from different institutes like Government College of Engineering, Belgaum, GRT Institute of Engineering and Technology, Tamil Nadu, YCC, Nagpur, Government Polytechnic, Ahmedabad, Weltech High-Tech College of Engineering, Tamil Nadu, Saraswati Vidyalaya, Nagpur, Shivaji Rao Jonve College of Engineering, Asangaon, Thane, DKPA Society Textile Engineering Institute, Ichalkaranji, KIIT Group of Institutions, Ghaziabad, and many more. These 2 workshops will be of full energy and knowledgeable for all the participants. So, all the participants are requested to attend all the sessions. I'm now very much thankful, Honorable Chairman Sir, Sri Sunil Raisani, respected Director Sir, Sachin Ujwale Sir, for kind support, and thankful to workshop team members. Also, I'm thankful to organization units, IEEE Region Team, IEEE Bombay Section, IEEE Nagpur Subsection. With this, YCC Nagpur, PIIT Nagpur, Cummins College of Engineering Nagpur for their support for signing this proposal of fund. So, thank you so much.
Thank you so much, sir. The reason behind the success of GHRC is the collective effort of its owners, management, faculty, and the students. But we would have been directionless without the excellent dynamic leadership of our director, Dr. Sachin Ujwale. I would like to request sir to kindly address the audience.
Thank you, Sumay. Am I audible?
Yes, sir, you are audible properly.
Yes, sir. Good morning to one and all present here. Chief Guest of the event, Dr. B. Satyanarayana, Chair IEEE Bombay Section. Guest of Honor, Dr. Abhay Gandhi, Chair IEEE Nagpur Subsection. IEEE Branch Counselor at GHRC and Coordinator of this workshop, Dr. Lakshman Patel. Deputy Directors, teams of various portfolios, heads of various departments, faculty members, participants, ladies and gentlemen. On behalf of J. Raisuni College of Engineering and on behalf, I welcome all present here to the inaugural ceremony of workshop on IoT applications using embedded systems. And IEEE 2021 capacity building workshop under CoE IoT educational activity. Organized by J. Raisuni College of Engineering, Nagpur in association with IEEE Region 10, IEEE Bombay Section and IEEE Nagpur Subsection. At the outset, I sincerely thank IEEE Bombay Nagpur Subsection for Bombay Section and Nagpur Subsection for bestowing us this opportunity. Sir, the G. Raisuni College of Engineering is an autonomous institution established in 1996 and is ranked 139th in NIRF. We have been ranked second in the self-financed institutions category awarded by the Ministry of Education of Government of India in the Atal Ranking of Institutions on Innovation Achievement 2020 and bestowed with a 5-star rating by the Innovation Cell, Ministry of Education, Government of India, New Delhi. We have recently been conferred with the platinum ranking by the Confederation of Indian Industry for our linkages with industries. So, 2 of our team members have received AICT Research Award, and recently 2 of our startups have been shortlisted at the UP 2.0 of Ministry of Education, Government of India. The recent advancements in the computational techniques, such as the machine learning, Internet of Things, and embedded systems accelerate the deployment of devices in various engineering applications. In this era and in the future, the AI machines will replace and play a key role to enhance the human capabilities in many areas. It will also make lifestyle better by providing convenience to all, including the normal human beings and professionals as well. The applications of embedded systems and IoT sector are working in many areas with huge impact and is being used widely as well. This is providing quality and efficiency in almost every area we are evolving in. I am sure that this workshop will be helpful in exploring this area, and I wish this will lead to more innovations and research. These testing times of the current pandemic will go, and all of us together will provide the best faculty, best facilities and initiatives to all of our stakeholders, and we sincerely believe that it is our moral responsibility to gain knowledge and spread this knowledge in terms of these types of workshops to the future generation who will take care of the future technology and build a strong ecosystem that is extremely required for our country. I once again welcome the guests and the participants to the workshop, and I am sure that this workshop will certainly have many takeaways for the participants. Thank you. Thank you.
Thank you, sir, for your kind words and for always standing and supporting with us. IEEE section has always been in top name, be it conducting workshops, coordinating and helping other branches, and bringing up the new always. This has been possible only because of the core member and with an excellent leadership of Chair. I now request Chair of IEEE Bombay section, Dr. B. Satyanarayana, to address the audience.
Can you hear me?
Yes, sir.
Okay. Good morning, everyone. Thanks so much for the nice kind words and introduction. Sorry for joining late. There was some technical problem, so it took some time to mitigate that. I'm really happy to join today, all of you on the call for the inauguration of the workshop on IoT applications using embedded systems. And as many of the speakers mentioned, this is under the IEEE 2021 R10 PTM10 capacity building workshop under the Center of Excellence of IoT and Education Activities. And of course, this is being organized by IEEE College of Engineering, Kanpur, which is a well-known education institute in Maharashtra and also in the country. And I would like to thank the director, sir, Dr. Sachin Dole, Dr. Lakshmi Pathway, the attorney, and the IEEE branch counselor and coordinator of this workshop, and of course my colleague, Dr. Abhay Gandhi, the chair IEEE Market Section. Since this new committee, the so-called executive committee, for a few months ago, we have been giving a lot of emphasis on by various student branches as well as other members to actually write good quality grant proposals both to the section, to the region 10, to which we belong to, and also the headquarters. And I have been also advocating very strongly that we must also be nominating ourselves to various, honors and awards that the IEEE bestows on people with a good volunteer skills. Now, why I started this by saying that within this last, I would say 4-5 months, since about March, a large number of such grant proposals, like what you see a result of that today, resulting in this workshop, have been written by my colleagues in IEEE Bombay section. Bombay section, of course, consists of a large number of colleges, universities, and institutions spread over Maharashtra, Goa, Madhya Pradesh, and Chhattisgarh. And I'm really glad to say many of those proposals have been now actually granted, and the funding has come, and a large number of events are undergone. And and equally important is that when the part of IEEE volunteering, like this is not our job of what a real really earns our bread and butter, but something which is something which will give us very, real satisfaction and happiness because we are volunteering something for the benefit of our student members in particular, and of course the ITC members at large. Now, when you do such thing, unless you report it, unless you actually write down and show and share with others, and the entire effort is unnoticed, naturally, because if you don't report, nobody knows that you have actually done like this. This is like saying I have done certain research work, but I never wrote a paper, publishing, basically the paper, then nobody would know, right? So somebody else, of course, would get benefit of it. So always remember that you must always document the kind of work or whether it is research work or volunteer work or any of these things like what you are holding, which are properly reported to the concerned authority. Now, coming to the Bombay section, of course, as some of the speakers mentioned before, we have been now geared up to organize not only just large number of workshops and student activities and various congresses and meetings and so on, but also we are poised to organize very, very high impact events this year. Of course, starting very next month, we are going to have a big event in your own space. We are in City Nagpur, the event called Indiscon, which I'm sure my colleague Abhay will talk about it. And followed by that, we have the section signature conference called IBS coming up in November. And later this year, we'll also have the so-called student activities, WIE and YP Congress that is going to come up. And the faculty Congress is going to come early next year. But the events to look forward to is the Region 10 signature event called 10th in 2020, which is going to happen in July. And that's a thought. In fact, as we are speaking here, a very nice workshop on entrepreneurship is happening online, in Mumbai, of course, but it's an online event where 4,000 participants have registered and participating in it. So the point is that unless you really bring the event calendar up and working live, the kind of main practice and dissemination of many technology areas to our students is not going to be easy and beneficial. Today, of course, when we talk about this workshop on IoT, and I'm not going to, in fact, the principal sir has nicely summarized the field of IoT, but these embedded systems and IoT have been kind of backbone for the current technology space, in particular in the context of Industry 4.0 and 5.0 to that extent. The fueling of technology based on the communication standards like 5G, etc., fuel furthermore the advancement in this area. But what I really wanted to kind of say 1 minute about the applications that are surrounding IoT is not something new, and we have been kind of using the principles that govern IoT for a long, long time. But what really spurred this major technology advancement is, the availability or low power sensors, which is again a part of an outcome from not necessarily the field that we are working here today, but also as far as the ways, like material science, laser applications, and so on. The self-organizing wireless sensor networks, which has been another major area of change the landscape of IoT. The low-weight data acquisition systems to pick up the data from the fields, which are often, harnessed by solar power and so on. And how do you build very, very low-weight applications, data acquisition applications? And one thing that comes very immediately, I would say, IoT applications is the possibility of, the data security, because that brings a big challenge, because on one hand you talk about low power and so on the other hand you want to also not compromise on the data security. So that's development. And how do you deploy these sensors in a vast field like in the applications mainly? Today we talk about IoT, the major emerging areas are medicine and agriculture. In agriculture, how do you ensure these are actually deployed in large scale? And these are, I think, some of those areas that one must remember, and I'm sure during the rest of the workshop, these are going to be dealt with the experts that are poised to kind of take the workshop to a forward area. Right? So I think these are some of the things that I thought I will kind of bring up today to you to say that we are right now poised very, very well, both from the point of view of the academic research and industry, and to work on various IoT areas. So therefore, of course, training ourselves into this will give a head start for the students to latch on to these technologies when they go out of college, whether they start something on their own like the startup, or they go ahead and join a kind of corporate sector. But I think these are very, very important to get into. I'm sure this workshop is going a long way to kind of bridge that gap. And once again, I kind of congratulate the organizers of course led ably by Dr. Lakshmi, and I wish the workshop a grand success. Thank you very much for
Thank you so much, sir, for your words of gratitude, and we are really humbled to have you with us today.
Thank you.
Ladies and gentlemen, we have with us another eminent personality leading the IEEE Nagpur subsection flawlessly and helping the section to grow heights. It's none other than Chair of IEEE Nagpur subsection, Dr. Abhay Gandhi. I request sir to kindly address the audience.
I hope I am audible.
Yes, sir.
Good morning, everyone. Professor Satya, Bombay Section Chair, Dr. Sachin Untawale, Director GHR CE, Dr. Lakshman Thakre, Branch Counselor at GS Rayaswami College, other team members and dear attendees. It is also a very, I am really thankful that you have invited me and given me an opportunity to spend some time with you all and share a few thoughts and a few moments with you. GS Rayaswami College has always been very actively associated with IEEE since a very long time, and I am happy that the trend continues in this year also. As all of us are witnessing, the pandemic has impacted all our spheres of life. But I don't have to, it is obvious that it is only because of the already widespread deployment of communication technology and the related applications and software that work from home was possible in a big way. And we could actually keep lot many industries going and keep lot many things going on because of all these applications. Just 2 years ago, no one was knowing there is something called WebEx or Zoom, but now everyone is using them as if it is a daily matter, just like Word, Excel, PowerPoint. Now equally frequently we are using this WebEx and Zoom. I wonder, even if this pandemic had come 20 years ago, I don't think we would have been able to cope up with it the way we are being able to do it now. So the point is that the communication technology is a foundation. It was there in place. But all these applications also need to be developed and matured and deployed on a large scale. And then you can see their impact on the society. And the same thing is bound to happen with Internet of Things. The overall motto of IEEE, what I have observed is connecting the unconnected. So right now we are witnessing the impact of people being connected so easily with each other, and they are able to collaborate and work so easily. So now the next wave is going to be connecting the unconnected. So whatever is left unattended or unconnected, ultimately it will be connected to the network. And some very new interesting applications will be coming up. So if these are all the things that are going to happen, obviously one thing that is required is large number of people who are trained for this area and who understand the nitty-gritty. See, knowing basic principles is essential, but it is not sufficient. If one has to work on that area, then knowing the fine details of that area are also equally important, and that is the kind of need I am sure this workshop will cater to, and all the attendees will benefit out of their involvement in this workshop. And as Professor Satya rightly pointed out, we have the INDISCON conference coming up at the end of August, and the conference's theme is the impactful innovations for industry and society. So we have invited papers mainly in the 5G and IoT and similarly automation, Industry 4.0, all these things, virtualization. So I request all of you to go through the website of INDISCON 2021, and you will see that most of the topics are very much related to this workshop. So it is kind of a good sequence that you can come to know the basics and some fine things in the workshop, and then down the line you can attend the conference and get an idea as to what is the exact status of research in this field. Because research is very important. Out of that outcome only some of the things are picked up and they get deployed, and then everyone benefits. So research is the starting point for all that, and all the academic fraternity, even the industry, if they invest into research, they are basically working for the future. So I am quite glad that all of you are contributing to this national effort, and you are also working along the tagline of IEEE humanity. So I'm quite glad to see that. All the best wishes for the workshop, and I would also be very happy if some of you register and attend the upcoming INDISCON 2021 also. Thank you very much.
Thank you so much, sir, for your kind words. Thanks to all the guests for taking out their precious time and gracing the inaugural function. Here, we have come to an end of the inaugural function, and we'll be moving towards the workshop after this. But before that, leaving with our tradition and considering it to be a new normal, I now request everyone to kindly stand for the national anthem.
जनगणमनाधिनायक जय हे भारत भाग्य विधाता सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा सब शुभ नामे जागे सब शुभ आशीष मागे गाहे सब जय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. So, moving to our session 1 of the workshop, which is on IoT fundamentals and implementations by Dr. Vimal Bhatia, Indian Institute of Technology, Indore. Dr. Vimal Bhatia, before that, I would request Lakshman Bhatia, sir, do we have Vimal Bhatia, sir, with us in the panel?
Yes.
Okay.
Sorry, sir.
Okay, sir. Dr. Vimal Bhatia is presently a professor in the field of electrical engineering in Indian Institute of Technology, Indore. Dr. Vimal has completed his PhD for digital communications from the University of Edinburgh, UK in 2005. He is currently senior member of IEEE and certified Scrum Master. He was also general co-chair for IEEE 2018. He is an associate editor for IEEC Technical Review years in communication and networking and wireless communication letters. We are grateful to have you, sir, with us. I now request you to kindly proceed with the session. Over to you, sir.
Sir, am I audible? Sir, you can share your PPT. You are not present. Yes. Hello. Sir, your voice is not audible. Your voice is not audible. Hello.
Yeah.
Sir, voice is not clear.
Is the volume low?
Hello.
Hello.
So voice is not clear.
Hello, can you hear me now? Hello.
Hello.
I can hear you.
Sir, it's not audible. It's not audible. It's not audible.
You're not able to hear me at all?
Now it's what is
Volume. Can you hear me now?
not clear.
Yes, sir, it is audible.
Is it audible now?
Yes, sir, it is audible right now.
Audible.
Okay. So shall I continue then?
Yes, sir. You can share it.
Yes.
Yeah.
Okay. 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 So let's yes. So essentially our area right aspects of communication. And we have active collaboration with sir, you can share your sorry. Yeah, because audio, I have yeah, okay, yes, sir. Right. Video is right. So share your yes. Yeah, actually, I think of because there is audio there. Right. You see this now? Yeah. Now it's okay. And audio is okay as well. Sir, audio is okay, but not clear. Please. And other participants having the same issue?
Sir, your voice is like audible, but it is breaking continuously and it's not clear. You can check once by removing your headphones, sir. Maybe that could be the issue, please.
Disconnected.
Yes, sir.
Hello? Now can you hear me?
Yes, sir. Could you please say something so that we can check?
Yeah. Hello.
We can hear you, but it's not at all clear, sir. Sorry, sir.
Okay, maybe I'll log off and send it again. Now it's clear, sir.
When you are keeping your mouth near to your mouth, we can hear you properly now.
Okay. Let me sign off and send it again.
Okay, sir. Okay, sir.
Yeah. Because I was in another situation. Right. Okay. Hello? 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 Can you hear me now?
Yes, sir. We can hear you.
Just the audio turn off? Okay.
Yes, sir. Like it is very low. We can hear you, but there's a very slight improvement in the
The
voice.
volume is low, okay? Okay.
Yes, now we can hear you, sir, properly.
Okay. Okay. Yes, sir. I'm just wondering, no, right? Is it logged in for two places? Only one place?
Hello? Hello?
Yes, sir.
Yeah, so am I logged in from only one place?
Only one, sir.
Only one, okay. Okay. I don't know why, yeah, when I logged in, okay. Um, can you see my screen? Hello? Hello?
Yes, sir. Yes, sir.
Yeah, can you see my screen?
Not clear. You are audible, but not clear.
Dear sir, can it is possible that you can speak without that headphone? Maybe that voice will come properly.
Okay. Can you hear me now? Hello?
Hello? Sir. Yes.
Let me, I have another, actually I have another set of questions.
Sorry. If you more in near to laptop, so then it's clear.
Okay. Okay.
Now it's clear.
Okay. Okay.
Yes, sir. Now
So,
it's clear.
I'll get another set of headset. Let me see if that works better. Hello, can you hear me now?
Yes,
Yes,
sir.
yes, sir. Yes, sir. So not audible. Not audible.
Hello? Hello, is this better? No?
Yes, sir. We can hear you now.
Okay, so I think I have to come closer to the,
In that case, sir, you can turn off your video and then come closer to your device so that it would be better.
okay, let me do that. Now you can hear me, right?
Yes, sir.
Okay. Okay, for some reason, this only that and okay, let me do that. Is that
So if it's possible for you to like log in or join through your mobile phone, so you could check because this session would be a very long, an hour-long session, and if
yeah,
we still face the audio problem, it would be very difficult for our attendees to understand your information.
yeah, yeah, yeah. Can you hear me now? Okay, let me do this. Okay, I'll try mobile phone. I'll say like I'm trying application instead of this mobile phone. Let me see that do it better.
Yes, sir. Please.
about this application.
So till the time viewers are joined, we can share his PPT on the screen now. Lakshman sir.
Yes.
We can a PPT of and we can bring the PPT of Vimal sir's bio.
Okay, so I see there is a small delay, but that's okay. I think I'll go slow. You can see my first slide.
Yes sir, your screen is presented.
Okay, perfect. Let me get this one. Okay, so finally, I can see her there. Okay, so first of all, here are small overview on IoT fundamentals introduction. Basically, I'm going to my phone. So my voice is coming from phone and video is coming through internet. So I'm using both the package and the package network in the same time for 45 frames. Okay, that's it. So you can see the second slide.
Yes sir, we can. The outline slide.
Okay, perfect, perfect. So we'll go over this quickly. So IoT, what is IoT? So IoT refers
to a system of interrelated, interconnected objects that are able to connect and transfer data over a wireless network without human intervention. IoT is the interworking and the networking of physical devices such as vehicles, vision. So it's not necessarily limited to only a certain thing. It is limited vehicles, buildings, human beings, anything. So that's what called as Internet of Things. And then embedded with electronics, so there's some electronics that is there. We have a software which is running on it. Then we have sensors, actuators, and network connectivity that enable these objects to connect and exchange data. Now, IoT as as International Telecom Union, it is a standardization making body for our telecom area. So we have so they saw there was a big expected in the IoT market, in the IoT arena. So IoT can be viewed, so what they come up with their own definition, that IoT can be viewed as a global infrastructure for the information society, enabling advanced services by interconnecting. So we had things like WSN, so wireless sensor network or sensor network in the past, but here there's a change that they said that enabling advanced services by interconnecting. So ITUT, which is the International Telecom Union, they give in their recommendation, which is given below, the source recommendation ITUT Y.2016. So in that recommendation, they have given a definition for IoT that things are connected both virtually or physically, things based on existing and evolving interoperable ICT infrastructure. Because over the years, the ICT infrastructure will change. It's a very fast-moving technology. So every 10 years, we see one new G being added, right? We have 1G, 2G, 3G, 4G. Now we're looking at 5G being added, right? So they kept it open that it can be expanded in the future, looking at how fast things are changing in the ICT arena. And ITU is about, if you don't know, ITU is International Telecom Union, which is a body of various government. You can think of it like as a United Nations of telecommunications, where the representatives from different countries they come together with the industry, with academia, and other stakeholders. They come together and form some standards. And those standards are the ones that we all follow when we have our equipment made. So that helps us if, let's say, I have made an equipment which is suitable for 3G or 4G, let's say 5G. Now, if I have this 4G handset, I take it in other parts of the world, let's say take it to Europe or China or Japan. If they're also saying that it's compatible to the same 4G standard and in the same physical layer, technology, same stack, then I should be able to use my own, same handset there too. Similarly, we have different standards from IEEE that we come later in this slide. So IEEE, as you know, large publishing house and they're doing it under the auspices of IEEE section. So it's one of it's the largest body of electronics, electrical, computer science engineers across the world. And I think that the maximum one are from India, I think the largest numbers are from India. So here, there, IEEE also, along with the journals and books and other things, they also came up with different standards recently in the past 5 to 10 years. About 20 years or so. Yeah, 20 years. So they have been very active in standardization as well for wireless. We see wireless LAN as one of the standards that we use every day. So we are connected in our college campuses or home to Wi-Fi. It's a wireless LAN standard. Then we use other standards like Bluetooth and all that. That's a different body. But I'm just focusing majorly on IEEE and ITU. So IEEE also came up with things like WiMAX. Some of you might have heard about it. But somehow, over the last 2 decades, we've seen that IEEE standards, they are very successful in indoor type of environment. Whereas when we go outside or we need mobility, then we go for the ITU. So we are, in our homes, we are connected to Wi-Fi, and when we are outside, we are connected to our 3G, 4G networks or something. So this is how somehow the industry and the users are now getting got used to it in the last 2 decades. So ITU thought there was a big revolution coming in IoT, and they came up with their own definition of IoT, and this definition is in their recommendation via the 2060. So what are the fundamental characteristics of an IoT network? So IoT networks are interconnected with regards to IoT. So anything and everything that needs to be connected somehow. Then heterogeneity. Now you can use different standards, but they should be able to talk to each other. Right? For heterogeneous means it could be, and also IoT does not mean that you have to take a particular hardware or a particular software. So you're not tied to hardware or the software. You can use any of those, and you are connected to a network. Now, these devices or service platforms, they will talk to each other through the internet basically. So that's called Internet of Things. Then it should also be characterized by dynamic changes, because the systems or things are changing dynamically. The scale is there, that is the next slide actually, but other things I can say about dynamic, that you might have different sensors which are, let's say, mounted on they're mounted on a vehicle. So if they're mounted on a vehicle and the vehicle is moving, then you will be the sensor that is connected or the device that is connected in the vehicle would be seeing different channels, right? It will be, because it is moving, there will be different type of settings, there will be different realization, and maybe there will be certain conditions where, let's say, you are moving through a tunnel or on the backside of the hill, you might lose connection. So there are dynamic changes. Other things could be that some of the devices or sensors would be switching on, like it will be in a sleep mode and then wake up mode. For instance, if you have a sensor like a temperature sensor, which needs to, you have put it in your farm or your campus. So in your campus, there is just in one corner, you have put this temperature sensor. It will sense the temperature and then send you all the humidity levels or something which may need some information to be sent. But only it doesn't need to send it all the time. It can send it across maybe once in an hour, once in 2 hours, depending on your needs. Right? But if you compare this with, let's say, the other type of sensor, let's say they are in a chemical plant which is controlling the boiling temperature, or maybe in the foundry. So there might be a need to have an instantaneous value of the temperature known. Right. So there are these two different applications. So for one application, you might need connected all the time, whereas in other cases, you may not need all the time. So the changes, the situation and things are changing dynamically. Right. So they need to be, the IoT network needs to be dynamic in nature. And as it says here on the slide, that include location and speed. Let's say you have sensor on the vehicle, so vehicle will have different speeds, from 10 kilometers to 100 kilometers. It will keep on changing. Location will keep on changing. So it should be able to change dynamically. It should be compatible to dynamic changes. So enormous scale, the number of devices that needs to be managed and that communicate with each other will be at least an order of magnitude larger than the devices that are to the current internet. Now the ratio of communication triggered by devices as compared to communication triggered by humans is increasing. So now we have more number of devices communicating with each other than the human beings. So if you remember 1G, 2G, 3G, it was always the human beings that will initiate a call or sending some data. But here, with the IoT revolution, we are seeing the devices talking to each other. So they're moving on. So this slide shows us what is the ratio of how human beings number of devices have changed over the years, connected devices. Right? So if I look at this slide in figure number 1, in 2003 the world population was approximately 6.3 billion, and there were around 500 million connected devices. If I take the ratio to connected devices per person, I get a figure of 0.08. So it's about 8% of the human population. Then around 2007-2008, this number came out to be equal. In 2010, our world population was estimated at 6.8 billion, whereas the connected devices were estimated 12.5 billion. So there's already a factor up, approximately close to 2 we were getting there. 2015, the world population stood at 7.2 billion, whereas connected devices were 25 billion. So we were at around 3.5 times the connected devices. So there are more number of devices than the human beings. And in 2020, this figure was about 6.5. It's about getting close to 7 times the human population. So as we go forward, we will expect probably around 2025, it will be maybe close to 10 times the human. So we have, after the human population was 7.6 or 8 billion, the devices will be around 80 billion devices. So our factor is going very fast. So hence, anything of an IoT setup that we're going to develop, it should be scalable. So IoT as such is not a new technology. As to the IoT, in terms of Internet of Things, it has been known for the last 16 years or even more. An idea came around 1970s that the devices need to be connected. And then around late 1990s or beginning 2000, we would hear words like pervasive computing, embedded internet, and internet was very hot technology at that time, very new and very hot technology. A lot of e-commerce and things were in the start at that time. Probably it was a bit too early to bubble burst, and around 2010 we saw the big growth in e-commerce in India as well. So now in the year 1999, Kevin Aston used to work for Procter & Gamble. P&G being a company mostly into FMCG products, pharmaceutical or other things like cosmetics and dairy products and all. There Kevin was looking to optimize the supply chain of development. So he had an idea of using RFID. So these RFIDs are near field communication based things we are using so much these days, in getting access to this, even working with credit cards, and they're also getting these technologies in metro station and other stations. We just need to tap the card and then they're going. So this technology was really taking shape around this early, early 2000s already. Yes. I saw some using in Singapore, some places were already using these. But because of the internet was very hot in late 1990s, he said, okay, Internet of Things, these things will be connected to Internet. Now it got attention of P&G executives, but the word IoT still remains buried. It didn't come out for another 10 years. It became so popular. And probably if Mr. Kevin was working for one of the technology companies like Microsoft or Google, it might have come out earlier. But anyways, that's the history about IoT. But let us look at some of the challenges of deploying an IoT network. So implementing an IoT, again, is not an easy task for any means. We can use smaller ones in our home something, but if you want to really scale it and maybe try to get it to the full potential, then we need some expert advice and for the success. So to understand the gravity of this task, we'll look at 5 major components of an IoT implementation. So we have the first one is sensor, second one is network, standard, intelligent analysis and intelligent action. So the first one we'll cover is sensor. Now, as I said, in IEEE and in this program, IEEE, and I think most of us as faculties would be member of IEEE, one of the sections. Now, IEEE came up with its own definition for sensors. So it defines a sensor as an electronic device that produces electrical, optical, or digital data derived from a physical condition or an event. Then they said the data produced from sensors are electronically transformed by another device into information output that is useful in decision making. So here still the focus is on converting the data from one from let's say using converting from the optical to electrical and then different forms. But as we are going forward, we will probably in the future, because now a lot of this computing is moving towards optical domain itself. So we might see an optical sensor and the network in optical as well, maybe using optical fiber. Or if it is indoor environment, might be using visible light communication. So it might be all optical. There may not be a need to convert from optical to electrical, but as we stand today, yes, our processors, all the number crunching that happens, it all is happening in the electronic domain. So it is converted to electrical domain, so bits and bytes, and then handles. But it is possible in the future. It is possible to do everything in optics. Now let us look at 2 different broad classification of a sensor. There is an active sensor and a passive sensor. Now an active sensor is the one where it will apply some power source. So like in COVID times we saw use of pulse oximeter. So it is a sensor, but it is an active sensor. We use a battery to operate. Similarly, our BP machines, sugar machines that are now even used at home, they are all active sensors. Some of the temperature measurement like the thermometer and all these, they are all active sensors. Now, passive sensors would be something like which is generating power by itself. So one example could be a piezoelectric one that we have seen, someone might have seen in YouTube and other places where people are putting it on the floor. Let's say in a shopping center or even in a busy place like a railway station or something, you can put it on the floor and people step on it, produces some electrical energy, and it can be used for counting the people by itself. So it is a sensor which can be used for multiple use, for generating electricity plus also counting the number of people or the movement, the number of steps that has occurred on that piezoelectric map. Other examples could be your sensor checking for, let's say, the wind speed. For sunlight, so we have solar panels. They could be, also used for, or some values can be calibrated for lumen. So it can tell you how much light there is coming from the sun. So these type of sensors, like flow meters, might be embedded within the pipe. When the fluid is flowing through, it moves so fast and it can generate its own electricity. So these are classified as passive sensors. Now, we've seen already the purpose of temperature, motion, and all. So there are various factors about the sensor. Then sensors also need to look into the accuracy of the sensor. As a user, if I'm doing an IoT deployment, I need to look at how much accurate the sensor I need. So let's say you are purchasing salt or dal or rice or whatever from other things. So the weight will give you some values, which is okay. Maybe the accuracy up to 0.1 is okay for you, or there might be some deviation is fine. But let us say you are going to do it for the other application, like if you are measuring gold or something more valuable, then you need to hire them. Then reliability. Reliability of a sensor is also very important because again based on the application. So let's say you are having a sensor or a camera fitted onto an airplane for measuring something outside, then they need to be very robust. Right? And because the conditions are different and they will be very, very reliable. You can't really afford, like in a spacecraft or in the airplane. However, let's say if you're putting a temperature sensor outside your office buildings or campuses, then it is okay. You can still replace them. If you're using at home, then the reliability is okay. If it works fine most of the time, it is okay. Or even if it needs replacement, you can easily replace it. It's not very expensive. So there the cost will play using a more role than the higher role than the reliability of a thing. But whereas it's putting into spacecraft or let's say autonomous vehicles or airplanes and all or defense equipment. So their reliability is very, very important. Then we need to look at the range because if you're doing let's say your IoT setup, we can't use the same range of sensors and applications. Let's say your application is for let's say temperature measurement. Now you are going to set up something in Antarctica or Arctic. So there you will have temperature sensing, let's say from minus 50 to plus 10 degrees or so. But if you're doing somewhere like in Indore or Nagpur area, so you really expect it to go below zero. So you'll have sensors measuring from let's say 10 to 50 degrees or 60 degrees. So outside temperature. So that is the range of the sensor we need to decide. So if, let's say you're working for a foundry or chemical plant, then the ranges will be 100 degrees. They don't need to be worried about 0 or minus 1. So based on your application, the range of sensor is also designed. Resolution also, is something of interest from the engineering point of view. Okay, in theory, we'd like to have the highest resolution possible, but in practice, our hardware is limited in the number of bits it can process, and the larger the number of bits you want to process to identify a particular quantity, then your compute and processing power and the memory, everything goes up. So here, in order to balance, we use resolution which is sufficient for our applications. Right? So let's say you are doing temperature measurement of a human being, you might be okay with the resolution of only one decimal point, so 0.8, 0.1, 0.2, it is okay. You need not need to know 0.008 or 0.001 degrees, right? So that will also define how and how many bits and what resolution we need. Because again, the A to D converters and those things will the cost in their implementation will increase. Then the last one is level of intelligence. So over again for the last decade or so, as the number of sensors we use in everyday life, so they have really increased. If you look at your typical smartphone, so you already have about 6 to 10 sensors built in for lighting, taking the lighting from taking the GPS coordinates. There's a lot of different sensors already. Some might do temperature sensing as well. Might tell you about how much you have walked. So there are various type of sensors already built into the sensor. Now they are now getting more smarter because now we are having capabilities of removing noise and interference. Now if you look at your smartphones, let's say when first time you purchase, you use the camera, the pictures are good. Even after a few scratches, the picture still comes out to be good, but there's a lot of noise cancellation or interference cancellation that is nowadays built within the sensor or some of the processing software. So over the years, their reliability, their handling of noise and interference has also improved. And that will see more. So that is one good part, that as we move forward, we'll see that with the technology of sensor will become cheaper, smarter and smaller. And then the second step in an IoT, successful IoT net setup is networking. So you need to connect these sensors. So once you collected the data, what do? You have to send it to some centralized. So how will you do it? So a network. Now, how can you connect to the network? Wirelessly or through wired mode? You can use a LAN. On the scale as well. So we tell you if it's a local area network or wide area network or metropolitan area network. So based on that, we can set up your routers and bridges. Then various technologies can be used on the physical. It could be a Wi-Fi, to the Bluetooth, low power Wi-Fi for IoT applications, WiMAX, LTE, 4G. There will be some modifications. We'll look at them as well, which will come in the next two slides. And then there is another paradigm of Li-Fi or visible light communication systems. So they can, as I said, no, you could have in the future that everything, even processing of it happens in the optics domain. So there are various types of, you see the sensor or the medium through which we can send this information back to the center. So now this figure shows us how the data rates have increased. So on a 1G we were about 2 kbps we were happy with it. To around 14 to 64 kbps, we could do regional signaling, we could do voice transmission in real time, and across the world we could talk to people. 3G improved it even further, like some things like voice and video telephony. 4G increased it all, so everything moved to data, and the cost is really low as compared to what we used to pay for 2G services. Then 5G we are expecting even more changes there, and it is going to be a revolutionary again a revolutionary thing for the 5G, for the IoT. You can hear me okay, right? The voice is clear? Hello? Hello, so I'm on a flight that says network. Is that clear? Hello? Hello? Can you hear
Hello?
me?
Hello?
Hello? Yes, my voice is clear?
Yes, sir. Yes, sir.
Okay. Thank you. Okay. So, yeah, looking at the network, so we had adoption of IoT network where we have a high data rate. Now we have low prices. Virtualization is another technique which has really, helped and improved over the years. So we have these data centers and all. You need not now have your own all set up with you. But you can always purchase some appliances from them. So if you want to increase the memory or have more number of GPUs, you can always borrow them or lease them from Amazon and other providers. And this has really, increased this application like anything as a service or software as a service, platform as a service. And the development on IPv6 is something which is underrated in most presentations and all as well. But this is one of the technologies that has really is enabling IoT revolution. Because IPv6 was very famous or hot around the late 1990s when the internet boom was happening. So a lot of migration of existing protocols started to happen around late 1990s, 2000. But then there are not that many papers of it at that time, and they thought that IPv6 addressing is sufficient. But as we move towards the IoT revolution, it was realized that it is not sufficient. The IPv6 is a solution to it, and now I think there are some more modifications happening to it. But the idea was to have an infinite number of IP addresses that can be generated. So IPv6 is a really interesting technology which was again not much successful in the beginning, but later on everything moved to IPv6. And nowadays we are using the cloud-based services. Our this portal of migrates to cloud-based service. We are using WebEx or Google Meet or Google Workspace. So all moving towards things. So networking and the other aspects are very important for IoT setup. So here, the challenges faced by IoT is an almost total number of devices. So let's say today you put 100 sensors in the campus to monitor different things, but as you go through the utility, it might go to 200 or even increase. And so the network has to be scalable. Then availability of network coverage, that's a challenge, because if you have, let's say, sensors put in some part of the building, so now we are seeing sensors to be built, embedded within the building itself when the buildings are being formed. So they will need with the 5G, there's a API to have, let's say, 10 years of life. So it is using some kind of energy harvesting and all. So basically saying that it is sensor is embedded somewhere where the coverage or having a power cable may not be possible. So you need to look at some of these advanced techniques like energy harvesting and simultaneous wireless information and power transmission. So there are a lot of these new techniques that are coming up to be able to do this. And then we have a solution to network coverage is to using cooperative network. So let's say you have a vehicle which has different sensors. Now, if that vehicle is autonomous vehicle and it goes to hills, then it may lose connection. There are a lot of people in Nagpur, Indore area, there's a lot of ghats there, so we might lose connection in the dark, and vehicle may go may not be connected. Or if it goes to some tunnels in cities and other places where there's no connection. Okay. So using cooperative or some other techniques can be used for network, increasing network coverage. So that is a challenge. Security as well. You might have different sensors that are in a place outside. There might be some eavesdropper. Somebody might hack the system. So security is another issue to be area of. And then power consumption. So as I said, that there is in one of the applications for 5G, if you have a battery life of 10 years. So getting 10 years currently is not feasible for all the applications. So some applications where more power is required, and there might be a provision for harvesting from sun or RF harvesting, then it is feasible. It is feasible to have that is kind of setup. Now, the third case, once you have got the connection and all, then of course you're going to use some kind of a standard to send this information. So the standards, I said in the beginning when we talked about IEEE and IEEE. Now standards are the ones which are enabling actually our ICT revolution, because it's not that in India we have a different standard and other places have different standards, and then we could not use our telecom equipment across. There will be so many translation of these protocols will happen. But here, because of the standardization, a lot of us are using the same standards across the world, and the same thing can be used for our IoT setups. Now, you could, let's say, have a farm somewhere in Africa or wherever, but you can still monitor it in India again, because whatever information, whatever data is being transmitted is encapsulated or covered within different packet sizes or different protocols. But because the standardized protocol, anybody can understand. So you can understand, you can have different equipment from different manufacturers as well. You still understand the same protocol, because they are again complying to a standard. So some of the typical example of standard would be like Wi-Fi. We're using so for communication protocols, DHCP, HTTP, or others. Now, along with the standards, there is a need for regulation. Because someone can say that, yeah, okay, they are compliant to a standard, but they may not exactly be. And there are also concerns these days about security and privacy of the data. So that needs to be regulated, how the security and the privacy is handled in the network. So, like in the States, they have FCC, Fair Information Practices, HIPAA, and also here, in India also, like we have the Bharat standards for the mostly for the electrical connections and cables. We had ISI marks. Those are different regulatory bodies. And then we have in telecom we have TRAI. Right? So it does regulation as well. That if they are saying that the base station is going to send radiations of these decibels or these frequencies, then they should be compliant to the same. Similarly, for different handset manufacturers as well, they need to be compliant with that standard. Now, there is actually no such standard we see in the in the computer science world. We really see in the networking, but others where they're doing analytics and all, they're still not there. But yeah, that's how it has. So standard, like for handling data, there are still these are applications like SQL for imaging databases or those SQL when it's unstructured data, that is there. But privacy and security is still very open, and people do their own implementation. Rather than going through so let's go to this to the fourth stage of this. So once you have collected the data, we have a sensor. We pass it to give some kind of text. Three parts are covered. Fourth part is internet analysis. So once we have collected all this information, what do? We have to process and analyze and take some action. So this stage of analysis is called as internet analysis. So nowadays using machine learning and AI-based algorithms to learn and make more to understand more different forms of information using voice data. So, for example, like if we want to do predictive or prescriptive analytics, so we can have, let's say, for example, like a computer vision, where we are trying to identify different objects, scenes, or activities in a map. So this all can be handled by a computer vision using machine learning type of techniques. So, or natural language processing. This refers to computer's ability to work with the text the way that human do, thus extracting meaningful information from text and even generating text that is readable. Speech recognition, we have been doing it for many years. So some of these things could be used. Let's say in case of we had in the COVID era, some places they have used CCTV to or some audio things to find out how many people are actually congregating. So there is from the camera you can see how many people, and then you can apply one of these algorithms to find out how many people are there. So estimate the number of people, or let's say social distancing is maintained or not. So these are the some of the analytics model that can be that where the application is right for so AI models have been used to implement them, but again you need to know how to use it. That's one of the challenges. That's in the next slide. Okay. Then about outsourcing. So one of the examples that we saw being used very commonly was use of RLG2 app. Right? In India we use it quite often. So where we could know where the people outsource data. People are putting their own data into a positive or a negative space or something, and then you would know that where the person is, how close it is. Similarly, we have used Google Maps to do the directions. So that's also a lot of the data that goes into the Google Maps, which tells us the real-time information. If there's a traffic jam or something, is crowdsourced. Right? So we also previous structure, you can click on it, and then the next person who is planning their journey, they cannot plan accordingly. That there is a delay of 10 minutes or 15 minutes or 10 vehicles are there at the moment. So a lot of this information nowadays is coming through crowdsourced. So real-time data processing and analytics, every single, not going with it, but there are things like, as I was talking about the traffic monitoring or management, it is real-time information, right? If it is processed after now, things would have possibly changed. So these are some of the challenges that are being faced, or challenges for adoption of intelligent analytics within IoT is the inaccurate analysis due to flaw in data or models. So you need to be someone skilled in this area to understand the models. There's so many models available for machine learning and this one. Which one is which algorithm is put in? That is something that someone who has worked in this area would be able to tell you easily, or at least can you can try 1 to 3 of different models and then see which one is the better result. So that things like there will be some outliers. So how do you handle the outliers? Sometimes they're not important, sometimes they might be important. So I think not one algorithm can be 32 on. So legacy systems, now that is commonly if you have a legacy system, then they may not be able to resolve the unstructured data that is coming from various sensors in IoT network or setup. Because let's say you are doing a setup in your campus, so you have various departments, they have different needs. Somebody in agriculture might have need for humidity or knowing the level of pesticide or manure or some nutrients in the soil. Then there are other departments which require the temperature control to be there at various different degrees. So having, let's say, getting all the information central store, then having this unstructured data might be an issue because we are not going to structure or put them in the same way. Then legacy systems to handle again real time because there's a lot of analytics that needs to be done, and it has to be done in some cases in real time as well. In some cases you can do it offline, that is fine. You can collect the data, we can process it. So many times in the research area will be collecting the data from an open source or some other. We do it around test. So here we are collecting the information and then processing it later. But when it comes to real-time applications where it is required immediately, then there's a different set of solutions that needs to be located. So for example, let's say you're doing imaging for looking for cancer or something else, or let's say there's some issue with like we're doing for plant seeds and all. So there it is probably not required to tell immediately what is it. It's not the same as let's say making a decision by autonomous people. If it has to stop or take a right turn or a left turn. So it can wait, but in some applications there is a need for a immediate action. Now this small typo here, this is an intelligent action, right? So the title should be to read as intelligent action. So here in intelligent action, we are saying that machine to machine, machine to human actions can take place. So this is with the coming up of new advanced user interface and user experience technology. So factors driving adoption of intelligent actions will be lower as the machine prices improve machine functionality. So machines are going to talk to each other. And of course, deep learning tools, that is already happening. If you're trying to do, let's say, automation of a factory floor, then machines can talk to each other. They can set up, let's say there was a fire or something, so machine can tell the other machine to switch off in the network in the before or after, and maybe switch on the sprinkler of the fire, the water sprinkler automatically. So where there is no need for, there's no even requirement of a human intervention, machine can talk to each other. That's one of the things driving the industry 4.0 revolution. So 4.0, without the ICT technologies, without IoT technology, it cannot happen. And I'll show you a few more slides that IoT networks or IoT knowledge is required in that particular area. So these are basically the 5 major things which are required for an IoT setup. So IoT is an ecosystem of ever-increasing complexity. It is the next wave of innovation. In summary, so convergence of technologies will make IoT implementation much easier and faster, which in turn will improve the aspects of our life and work in extent. It is already making changes. So some of these IoT components are things which are, say, vehicles, human body. So things as Mr. Director open so it cannot be classified as electronic vehicles or buildings. It is vehicle, buildings, human body as well. Now, so we are researching on the molecular communication. So that is about how using the human body we can communicate. So there are various applications within the human body as well we are getting for. So there could be some in future we will probably have some machines or some sensors actuators embedded within the human body as well to do, let's say, targeted drug delivery, identification of the human being, or even telling you the real statistics about your BP, sugar, other levels as well. And other things which are happening right now, where we see IoT in fridges, bulbs, washing machines. So, for example, in the fridge will tell you that you are running short of milk. It may even order the milk for you. That can also happen automatically. Like, we have seen them in our printers these days. In their printers, they tell us that, yeah, you're running low on the ink. You would like to order, so you can go online and order from HP or Canon. Directly, you can go to the website and order it. Some of these things will be also automatic. So, instead there is washing machine, microwave, selecting the presentation of IoT, including RO systems and all. And nowadays, also, you see, this is, in advertisements as well. In on television, when you look at advertisements for air conditioners or washing machines, all that thing is IoT enabled. So, a lot of these things are already happening. We are seeing them coming to our daily life. Now, sensors, there are various types of sensors and some examples, and some of them you can actually find out that they are probably already there in your smartphone. So, we have a GPS, accelerometer, gyroscope, temperature, heartbeat and RPM, heart rate, light intensity, RFID. So there's a lot of these sensors that are already there. Okay, so now we'll look at another figure. So this is giving us a full overview of an IoT architecture. So we have boxes there. Not going to say any particular technology, but there are various technologies that can fit into one of these boxes. So, but if you look at the top, we have the top blue says things. So that is where the cyber physical boundaries are there, where the physical world with human being or the environment that we are living in, that's where the things are. And then there is a device. So within the device, the two things that interact with the outside world are sensors and actuators. So sensors, we call with a form of data. So sensors will collect this information from outside world, outside environment, and actuators are the ones that will do some action. For example, I told you about this, let's say sprinklers, automatic sprinklers, or even automatic braking systems in case of autonomous vehicles. So these are some of the examples of actuators. There is one slide in which we can tell a few more. Then once the sensors have collected data, then they are all, anyways, it's part of an electronic system that's run through some kind of a CPU. And that, could be anything. So I'm not saying that you use Raspberry Pi, Arduino, or your Intel machine or Mac. So it could be anything that you can do compute for you. Then running an operating system on it. And after this, there has to be some connectivity. For Internet of Things setup, you need to have connectivity to the network. And after there's some data transport protocols that are there, OP gateway, and then you finally end up in the Internet. And after that, because the data is all collected, you need to store this data somewhere. There, we can use different type of databases. Could be MongoDB, Apache, or various other forms. Then we have to process this data. Some of us use MATLAB for processing this data. Some use cloud-based services. So nowadays, there's a lot of things available online on the cloud you can use to analyze this data. So we can use Python and other various platforms to do this. Then application servers and middleware. Now these are the ones where you can do billing information or navigation or remote control of it. Okay, so there are different services which are running there, controlling the middleware, and then finally there is a presentation, because nowadays we use different types of UI, different platforms. You can have it on the mobile phone or web, and mobile phone also Android, iOS, or other Windows One, and then there's a desktop market as well. So we can have set up in different ASP applications. Some of the components for selling about actuators would be motor. For example, in an autonomous vehicle or autonomous drone, we are doing some action in the physical world that will be done by motor as well. There are different LEDs are there. Then different speakers, brake controllers are there. So you could use any of these, one. Right. So now let us look at the other. Okay, let me just go back. Yeah. For autonomous vehicle assembly, there will be this brake controller. So now there are various devices. I'll make view. Yeah. Okay, so we have different devices and components. So we have a CPU board. We have Arduino. It will be Raspberry Pi, Intel Edison, Qualcomm. So there are various types of hardware that can be used. And different OSs. So it could be Linux, FedEx, ARM, Embedded C, Arduino. So there are various platforms that could be used. And then for other type of communication, so media access could be through 2G, 3G, 4G, now 5G, Wi-Fi, Bluetooth, Zigbee, Dash, then data transfer could be HTTP or some other forms of transfer protocol. Then of course get and internet. So now I'll change a little bit to the connectivity solution. Now currently most of us are on 3G or 4G. So using LTE advanced or LTE, but we are in that region at the moment. The technology is still, so we can move towards 5G later on. Then in the IoT, it's called as narrowband IoT. So the reason why we want to go here was that it was also, as was before that, it was seen that we need to have a setup where an ICT infrastructure where we are expecting billions of devices to be connected. Now, if I use the current technology, like LTE or even Wi-Fi and all, they are all doing a fixed allocation of the time and frequencies to different users or different devices. But it's still doing a fixed allocation. But all the devices may not have the same need. Like here we have, let's say, different sensors. So some of the sensors which are doing temperature sensing, they need only a few KB of information every hour or so. Whereas if you are watching an IPL match or watching a football match or watching film or TV, you need high Mbps download speed and all the time. So this program, you need this. Right. So there are different application uses here. So let's say you're doing a deployment of a 4G based IoT setup. Now you might have different sensors in your campus, you have different SIM cards installed there, they're sending information to the base station, but they're all using the same clock. But their use is very small and intermittent. So then it was realized that because with this revolution, we don't really need some of these setups, we don't really need so much of bandwidth given to them. And compute was also very expensive, it drains battery as well. But here there was a solution proposed from release 13 onwards of 4G, where there was a branch from the standard. And that branch was basically to work on the narrowband IoT. So here the reason says narrowband because we use a smaller band to do communication between the sensors and all. So hence it was called as an NB-IoT because it is designed for an IoT setup where there is a need for small data array at smaller time larger time intervals, and there is relaxed requirements on latency, data rate, and mobility. So it was basically the first time it was designed for a very static type of environment where you have sensors as in a field or a campus type of environment. So other things, because it was coming from the GSM or the same family of standards, it was basically trying to reform the existing GSM with ANSI brain. There was no need for additional one. They started to use a very narrow system of 180 kilohertz in uplink and south allocation, because mostly these sensors are going to be sending things in uplink, then requirement for downlink, and also require a very small single subcarrier. So there's no need for, let's say, a full airplane subcarrier in some case, like in this 1024 subcarriers or 256 subcarriers. There's no need for that. They only use one subcarrier, which is capable of handling up to 180 kilohertz in uplink. And a lot of these definitions were also driven through the NTE. So things like channel coding, modulation, higher layer protocols, they're all borrowed from uh, NTE definitions. But they were relaxed. There was no need for a connected state mobility or voice. So you have, let's say, this user equipment or device is connected to a 4G network, to NB IoT network, but you are not doing any real-time processing. You're not even going to make a small voice call. So that's when you can, save on the battery life as well, but still able to have a IoT setup. Then later on, there were additions to this as goes on. In the recommendation, there were release 14, then there was release 15, where the requirements constants for different applications, so data rate was improved, multicast was added, positioning was introduced, and in release 15, there were improvements in the latency in power consumption features. So it is again evolving. So the NB IoT here it can be installed in your smartphones, smart homes, and other places. But if you look at here, so in 4G we started to talk about NB IoT, and then there was this common branch where the standard got upgrade to 4.5G and all. So here, in case of 5G, what we are expecting is what we are going to have actually is three different bands. So they are all driven by different industry verticals for different needs. Someone might need a higher rate but low mobility. Someone may need a higher rate and low distances, but someone may need larger distance to be covered, but then with a lower data rate, or might have a requirement for a high mobility with a lower data rate or analytics. So there are various industry verticals which require different things. So the solution is 5G, which will give different options to be used for different services. And they all come under the same standard, that is the whole umbrella standard for 5G. So smart homes is one application. Smart homes also with connected products such as which will make our life easier. We are already seeing a lot of things happening. A lot of these consumer products, software like Samsung, IEEE, they're all into IoT. The second big market we are seeing is wearables. There's smartwatches and all moving from smartwatches from Samsung, Apple, and others to Google glasses, smart gum and screen color-type satellite sensors. So this coming within. And then we have applications like smart city. So smart city includes traffic management for, let's say, water distribution, for waste management, urban security, environment monitoring, smart city solutions for evaluating the real nutrients. So smart cities without an IoT setup is not feasible. Then applications where IoT can be specified. Hello, yeah, can you hear me? So smart grid is another area where let's say you need to, smart grid is another area where we are seeing that connectivity will be through different systems. So we have a wind generator, we have other applications here. So let us say you had a power connection where let's say the connection got unlocked or so then can quickly be repaired using a smart grid type of setup. Now let me just go here. Yeah. Let's move on to other applications. So we have IoT can be deployed in industrial applications as well for market research. So IoT for industry 4.0 cannot go without the an IoT without an IoT setup. Then we have applications like in vehicle-to-vehicle communication. They all they run through the IoT setup. Then we have things like smart retail focused on the two different areas, improving customer experience, optimizing supply chain operations. Hello, is my voice clear? Is my
Yes, yes, sir, your voice is clear. Yes, yes, sir.
okay, perfect. Perfect.
Yes.
Yeah, I'll take maybe about 5 more minutes. Is that okay?
Yes, sir, you can continue till 12:30, or if you want to proceed with till the time you complete your PPT.
Yeah.
In whichever way you are
Let me take
comfortable with.
10 more minutes, so, and then we do our Q&A. Okay.
Sure, sir.
Okay. Application IoT can be deployed. So this is one application which is going to come up very big in the future. It's on smart farming. So we have farms of the future where we're expecting sensors, in tractors, different animals and all. Then there's a survey drone. So they're all connected to the network. So and then we can have a small control center within a farmer's house, which is just controlling a very large farm. Not possible for the person to go, so they can use server drones, can go to different parts in the farm and collect the information from the different sensors passed on the top and then given here. Then vehicle to infrastructure, that is something vehicle to anything is another application, or vehicle to everything is another application. So we can have see vehicles being more safer and comfortable. We can improve the reliability by using different type of sensors and by using autonomous driving. We have vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, vehicle to smartwatch. You're wearing a smartwatch, and there's in the smart city, the vehicles are known. So the vehicles and the smartwatch, they can tell if you're coming closer to the vehicle, it can alert the driver or can stop the vehicle itself. So things can be done, and vehicle to vehicle communication can also help us with this IoT setup. And again, traffic lights and parking places are all smart pedestrians. So there's a lot of automation and improvement in our current systems can happen. For example, we see in some places, especially abroad, where we have this pedestrian crossing areas where pedestrian will press the button, the lights will change color and then they move. And some places they are like fixed, again like three color things. So based on the traffic or the need, the frequency of switching on and off matches from the red to green may change using again automatic using an IoT setup. Then 5G as an example, yeah, we have different, so 5G will be another enabler. In 5G, we have different standards, like, new radio standards. So for vehicle also, there is a sub-part that again, so at least 17 millimeter wave MIMO connectivity with the vehicle to across the system. Then there are other standards like IEEE 802.11c. The recent VTech standard is based on Wi-Fi offshoot. So this is also using the current 5G or the future 5G setup. As a parallel to that, we have IEEE standard, which is 802.11c for vehicle to infrastructure communication. Then there are other alternatives as well. So just see them. So LoRaN is another technology which I'll just touch base that we can use it, which is becoming very popular especially in the agriculture type of application, smart agriculture. Um, um, Very smart agriculture is there. You can connect to the agriculture, you can connect your farming to LoRaN type of setup. Then there is another one where smart cities is coming. It is based on technology similar to CDMA, where they're doing communication lower than the noise level, so very small thing. So in agriculture somehow it has made lot of inroads. Also in smart cities or in let's say remote areas where we have different IoT setups, but they are connected very far away. It's not that any users are there, but whatever users are there, but they are very far away. So that is where LoRaN has really made a difference. It's a separate type of standard than through a LoRaN alliance. There's that's a context. So sensors usually are interested in monitoring environmental factors such as temperature, humidity, as well as health conditions of the livestock and chemical conditions of soil. So that's where LoRaN is really making inroads. Then this is one example that shows there is a user which is connected to REST or other APIs. And then we have an uplink from different livestock. So as I said, testing cows or assisted example, but basically there are some sensors there which are collecting information about the health of a cow or goat or whatever you have it on farm and sending their health or other information to the LoRaN cloud. Similarly for the plants and other type of deployments too. And then in downlink, there's an activation process where there's sprinklers and others, which can be used. So similar thing can be done through LoRaN as well, or through NB-IoT, or through IEEE standards. So there are various one of them, but this is, as I said, is one of the technologies that is getting very popular in this, where you can purchase off-the-shelf component, connect them together, and start working on large forms kind of application. So similar to the IEEE, they got 11 flavor as well of 11, which is going to be working on this 11 BA, so to work on the smart radio as well for IoT applications. So they are basically using low power and do communication. Right? So smartphones, so let's get this one. Then there are IEEE, again, there's another standard on P62704, which is for body area networks for human body for wireless communication, looking at 30 megahertz to 6 gigahertz ranges. Then P19012. Then there is ITU standard. Then, just let's go at the last one. There's various standards. So ITU has its own standard, that's Y410 at Y2213. And you remember Y2060 was for the definition of IoT. So they basically chose that is using the Hello.
Yes, sir. Yes, sir, sure. So participants, you are requested to put up your queries in the chat box, either to me or to the sir. It would be better if you put up on the sir. So they will be putting the questions in the chat box because we cannot unmute themselves. Yes. So the next question, and it was very informative, and I think it would be very useful for the participants. That is acceptable in the online and we are used to it. So, yes, sir. So have you received questions in the chat box? So it's a very understanding. Yes, I know what is that. Yes, I know. Okay, sir. Okay, sir.